In this introductory video, we're looking at the quantities involved with constant acceleration. I always write them in this order, spelling the word suvat. I then collect the information given in the question and decide from that how I'm going to solve the problem. The first quantity here, S, represents displacement. We should know that displacement is the vector equivalent of distance. It's the distance from a particular point in a given direction. In this section, we're going to be dealing with objects moving in a straight line. So they're either going to be to the right or the left of a starting point, and this is represented by either a positive or negative number. So we won't meet column vectors or ij notation in this section. The quantity u represents the initial velocity of the particle. Initial velocity or velocity at the beginning of the motion. Velocity, of course, is also a vector quantity. V represents final velocity, or the velocity of the particle at the end of the period of motion. As with initial velocity, it's a vector, and we know that velocity is the vector equivalent of speed. Velocity is speed in a given direction. The A represents acceleration. Acceleration is also a vector because it happens in a particular direction. Throughout this section, acceleration is assumed to be constant, although in some problems it may change from one value to another. Acceleration will be constant for a period of time. The final quantity here is time. Time is the only scalar quantity represented here. In most problems, the units of displacement will be the meter. The initial velocity and final velocity will be in meters per second. Acceleration will be in meters per second squared, and time is measured in seconds.